The circuit that is shown on the screen is called a differential amplifier. A differential amplifier basically amplifies the difference of the two inputs applied to it. So in this case, V out is going to be basically an amplified version. So A times V1 minus V2. So that is what a differential amplifier does. Okay, so to evaluate the response of a differential amplifier, I think the easiest way to do it would be to use superposition. Now, what do we mean by superposition? So we calculate the outputs because of the two inputs separately. Okay, so here's how we do it. So first of all, let's assume that V2, this input, so V2 equal to 0. Okay, and now let's calculate the output because of V1, and let's just call the output because of V1 as V out 1. Okay, now what is the voltage at this point? We could write it as V plus, but because there is no current here, so the current is 0 which is going into the non-inverting terminal. The voltage at this point is given by a voltage divider, where the two arms of the voltage divider are R1 and R2. So the voltage at this point is simply going to be V1 R2 over R1 plus R2. Okay, now if this voltage is applied at the non-inverting input, what is the output going to be? It is going to be equal to V plus 1 plus R4 over R3. Remember, that's the non-inverting amplifier. That's the gain of the non-inverting amplifier, right? And now we can substitute for V plus, and this becomes V1 R2 over R1 plus R2, and you have 1 plus R4 over R3 here. Now similarly, we can find out the output because of input 2, right? So we take away this assumption that we made here, okay, and we make V1 equal to 0 this time. So let's make V1 equal to 0. So if V1 is 0, then what is the voltage at the non-inverting terminal input going to be? So the voltage here is 0, the voltage here is 0. So what's the voltage here? That's also going to be 0, right? Because no current can flow through this R1 and R2. So this voltage is 0, so it's as if it is grounded. So then the remaining amplifier, this V2, basically is making an inverting amplifier here with these resistors R4 and R3. So because of that, you can say V out 2 equal to V2 minus V2 times R4 over R3. Now if you combine these two equations, V out 1 and V out 2, you get the combined output of the differential amplifier. And what is the combined output going to be? So let's write it here. So V out, let me write it in black. So V out equal to V1 R2 over R1 plus R2, and what I'm going to do is modify this equation a little bit so that we can write it like this: R3 plus R4 over R3 minus V2 R4 over R3. Now if we assume that the ratio of R4 over R3 is the same as the ratio R2 over R1, okay, so what we are assuming that R4 over R3 and R2 over R1 are the same. If we assume that, then the output is simply going to be V out equal to V1 minus V2 times R4 over R3. Okay, and that's the output of the differential amplifier, and therefore the gain of the differential amplifier is R4 over R3.